Hey guys, I will be explaining the Codeforces Round 806 Div 4. It's my first time solving all problems in any round in Codeforces. Okay, sorry for that cough because I'm still not okay. Let's start. Yeah. Alright, so for the first problem, you're given a string of length 3 and you want to check if it is equal to yes. And basically, it doesn't capitalization doesn't matter. So for example, this yes and this yes and this yes are allowed. So in fact, there are, I think, 8 versions of yes that can be accepted, but it's all about implementing it the easiest way. So what I did was I um, got the lowercase of each character since it's just 3. I don't know if there's a function that lowercases a whole string. Maybe you can lowercase the whole yes and then something like that. Actually, let's test it out. Let's see if it works. So something like this is what I'm thinking of. Maybe it would work. Oh, okay. So it only works for characters. Okay. Yeah. So yeah, that's basically it. Um, I don't know what's the best way to implement this, but okay. So let's go for B. Alright, so for B, just to summarize, basically you're given different problems, at most 26 types, and then you can solve, the teams can solve these problems. So the rules are whenever a team solves a problem, the team gets a balloon. The first team to solve a problem gets an additional balloon. So just to implement this, basically, you just want to count, basically uh, determine the number of distinct letters, right? Because the distinct letters, basically the first instances of each letter, is what gives them an additional point, and for each solve they get an additional point. So meaning it's basically just the number of distinct plus the length of the string, right? If that makes sense. So one way to implement that is basically create a set of characters and just insert them, and then you want to determine the size of the set and plus n. Okay. All right. So next problem is Cypher. So basically, you're given some form of code at the end, and uh, you're given the steps made. You want to determine the original sequence. So the idea here is that, okay, up, if you want to get the original sequence, you're just basically going to reverse the operations. So for up, you want to, I think you want to decrease instead of increase. And for down, you want to um, increase instead of decrease. Okay, then an additional constraint is that after applying on move 9, it becomes 0, and after applying the down move on 0, it becomes 9. So basically, we are taking the padlocks in modulo 10, or I mean the numbers for each wheel, it's just modulo 10, right? So how do we do that? Well, okay, so the tricky part here is the how do you take in the input and what the input is actually telling you. After you're done with that, just determine the maths. Okay, so what I did was iterated um, for every change in each wheel. So we have integer b, string s, and then I initialized the count variable. Okay, so for each character, what I did was if the character is d, you're just gonna increment the count. So basically the number of steps. You can also name this as steps. Or if it is U, then just decrease. So now the final output for that change would be AI plus count percent 10 plus 10 percent 10. So the reason why you don't want to stop just here is because the this thing can be negative. So this thing can be negative. Now if this is negative, then you can always just add 10 and then take modulo 10 in the end. So don't forget to print out the next line for each output. Okay, so the next problem is letter D. Actually, I'll prepare my scratch just in case I need it. Okay. So double strings, basically, this is very similar to the two-sum problem in LeetCode. Instead, you're talking about strings, right? If the string if there exist two numbers that that or actually two strings that when you add them or when you concatenate them, it's equal to the current string, right? So how do we do this? Well, one standard way. Actually, this is the problem that got most hacks, so you have to be very careful with the implementation. So the best way you can do it is to store the information in a data structure called map. Okay. So what this does is what the general solution basically is like for each letter, we're going to iterate all the possible like combinations of x plus y such that s is equal to x plus y, right? So like this. So we want to iterate that. So that will be like s1 plus s2 up to the length, right? And then it's also like one wait something like this in Python, something like that, or I don't know, yeah, something like this, and then 2 plus s3 up to the length of the string, something like that. I forgot Python. And then the final string would be s1 up to length minus 1 plus s of length, something like that, right? So these are the possible cases. So for instance, let's say Codeforces. Then we have, actually the string would be at most 8, if I'm not mistaken. Length of 8, so it's like C and then O D E F O R C and then like C E D F O R C and C E D E F O R C until C O D F O R and then C, right? So these are the possible cases. So why this wouldn't give time limit exceeded is because the length of each string is at most 8. So basically we have like a constant number of such strings. So it's at most 7 iterations per string. So you want to check each of that, and then you want to check if the first string exists and the second string exists. So there's no problem with that because the current string can never be the same as like x or y, x and y, right? So the current string or s can never be the same as x and y, depending on your implementation. Okay. So now let's go for mirror grid. So in this problem, I think this one is a very binary problem. A lot of people didn't just get it because it requires intuition as well. So how do we solve this? So basically, you're given an n by n, and um, in an operation, okay, each cell contains 0, 0 or 1. So yeah, so the problem is basically what is the number of swaps from 0 to 1 or 1 to 0, such that the original grid, yeah, the grid is equal to like the grids when it is rotated 90 degrees, 180 degrees, or 270 degrees. Basically, it's like symmetrical in 4 directions, or rotational symmetry, something like that. Okay, so how do we do that? Well, here's the idea how to get this. So I think the best way for me is to draw draw the thing. So what we will do is we have this grid, and there are two possible scenarios. If n is even, basically there's no middle cell, right? I think. Yeah. So what you will do is just check this here, this here, this here. So you want to iterate to all of these cells, and then you want to derive how to get to the other corresponding cells when you rotate it. So for instance, let's have x, y here, or let's say I and j. So this one, if I'm not mistaken, is j and then n minus I plus 1, assuming it's one indexed. And then in the corresponding side here, I don't know if it's accurate. This will be n minus I plus 1 and n minus j plus 1. And finally, in this side here, it would be, I think it's n minus j plus 1 and then I. So you want to check all of those squares, and then you want to determine for each um, quadruples, like what is the best uh, scenario for them. So should you turn them into all to 0 or all to 1, right? So obviously if the number of ones is like 3 and 4, then you want to make them all ones, right? If it's 0, 1, 2, then you want to make them all 0. That makes sense. In the case of 2, obviously it doesn't matter. So yeah. Now if it's odd, then it's just basically the same thing. You just don't want to check the middle part. So you want to iterate from n over 2 ceiling and n over 2 floor right here. This is the length of that here, and it will look something like this, right? And then this is the middle element, and whenever you're rotating the middle element, it doesn't really matter. So just the same algorithm as before. So how to implement this? Well, I took the grid, just to make things life easier. I made it one index so that I don't confuse myself. And then what you will do is iterate through all possible each quartet basically of the grid. So the first thing is the ceiling, and then the second thing is the floor, and then for each cell you want to check the 4 other cells, right? Or actually the 3 other cells. So what I did was I counted how many ones there are, and then I just took the minimum of 1, the number of ones, and 4 minus 1. And I added that to the answer. Okay. Okay, so far actually this is my favorite problem just because it's cool. But yeah. Okay, so now let us go for problem F. And I think a lot of people didn't a lot of people actually solve this using data structures such as sets and stuff, but I will show you a much easier solution. So you're basically given an array, a1 to an, and you want to count the pairs such that ai is less than I and aj is less than j. Okay, and obviously I is less than aj. So that's okay. So the intuition behind this problem is like, look at what is preserved in this structure. ai is less than its position and aj is less than its position. So before we count the number of pairs, we want to count, we actually want to mark all ai such that it is less than its position. And that's exactly what I did. So let's figure that out. So we have, say, a1, a2, a2, a3, and so on and so forth. And if ai is less than I, then we make bi equals 1, else bi equals 0. So let's give an example. Let's give this example. So 8 is 1, 1, 2, quite lagging because of the ventilation. So okay. So 1, 2, and 3, 8, and 2, 1, 4. So what would B look like? So this is A. So this is array A. So what would B look like? It would look like this. So this is 0 because it is not less than 1. Okay. And then this is 1, 1, 1, 0, 1, 1, and then 1. Okay. Now, how do we count the number of pairs? Well, we just want to basically pair, right? So for instance, here we can pair it with this guy, and then this guy, and then this guy. So how to count the number of pairs? Well, we can like just count the prefix sums. Okay, we take the prefix sums. Take the prefix sum. So pi would be b1 plus b2 plus dot 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 plus bi. And then if ai is less than I, then we increment answer by, so we increase answer by prefix ai minus minus 1, right? Because for instance, we are at here, we want to check greedily the prefix sum up here. Okay, that makes sense. So how do we code that? So for us to code that, what I did was exactly what I explained. I created an array of b, and it takes value of 1 or 0. So if ai is less than I, then bi is true, otherwise it's false. And then I took the prefix sums of b. Now to answer the problem, we take the answer, and for each time where ai is less than I will increment the answer by prefix of ai minus 1. Small little detail is to make sure that this doesn't overflow this thing, because ai can be 0, so it can be -1. The index can be -1, which is really bad. Okay, and then our final answer would be the sum of all prefix ai minus 1 such that bi is true. Okay, and then the final problem for this competition is letter G. So this one is the hardest, right? This one is the hardest, but it's also very interesting. So how do we solve this problem? The reason why first I found this quite annoying is because when I read the problem statement, it was very confusing. Like, it wasn't so intuitive to say that you check from chest 1 to chest n. It will be a nice problem if it's like, I don't know, you can choose whatever order. Yeah, but yeah, that's the constraint, is that you can choose from chest 1 to chest n. So now, how do we solve this? Actually, let's summarize the problem first. So you have a good key. You can buy a good key that costs k coins, or a bad key, which does not contain any, which does not cost any coin, but you will have every single number in the array. So meaning you will get less, right? So you can see why there's some conflict with these two, because maybe sometimes you need to use this, or sometimes you need to use this. And each key is one-time use only. So you're forced to buy, or yeah, you're forced to get a new key for each chest from 1 to n. Okay, so let's provide an example. So this 10, 10, 3, 1. So the optimal solution is to buy a key here. So you will get 5. You buy so good key, bad key, bad key. So what will happen is you will get 5 plus 3 over 2, take the floor, so 1 plus 0. Okay. So what happens here? So the optimal solution basically is we take the brute force, brute force. Okay. We do the brute force. And then the optimal solution is when we take the first I chests and use the good key there, good key, and the last n minus I chests and use the bad key. Okay. So that's the solution, the optimal solution, because it does not make sense to use the bad key before the good key, right? Why is that? If we divide by 2 first, then you take the good key for the other ones, and then you divide by 2, then that's just a waste, right? Is if you just think about it, like if you swap the operations, say G G B G G E B, if you swap, this is always optimal. This is always optimal. It only decreases once we add more B's before G's, right? It only decreases. Okay, so how do we do that? Now, consider this. Okay, so you will probably think, oh, wait. So if we take bad key for every single number suffix, is it a suffix? Yeah, for each suffix, then wouldn't that be like O of n squared? So it's actually not. This is O of n log ai for all I. Right? Because ai is less than or equal to 10 to the 9, so the number of divisions, floor divisions by 2 is at most 30. Actually, it's at most 29, because 2 to the 30 is equal to that, which is greater than 10 to the 9. So it's actually at most 29. So it actually is less than 30. Okay. Why is this? Because we're doing floor divisions. If we do floor divisions to 10 to the 9, sometimes it becomes odd, which means that we take out 1, right? If that makes sense. Okay, so it's actually less than 29, so it is at most 29. But it doesn't matter. You can make the upper bound maybe something like 32, 33. It's up to you. It doesn't really change much, because but obviously don't do it like, I don't know, hundreds and hundreds. Maybe that will get TLE. Okay, I don't know. Okay, so now we can actually just do it, right? We can actually just compute it for every single stuff. So you do G B B B B B B, right? You take this. Actually, B B B B is also possibility, right? Good, bad, 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 and then good, bad, bad, dot, 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 bad, up until we use all goods, right? Now we can compute this. This is just the prefix of I minus k times I plus the sum of the bad keys. So it will be AI plus 1 over 2 plus AI plus 2 over 2. Take the floor. So floor, take the floor, and then we divide by 2 again, and then take the floor, something like that. Plus dot 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 plus floor. So it's actually gonna be floor dot 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 AI n over 2 dot dot dot, right? And this is at most 29 floor divisions. So the answer is just the maximum of all of these. Okay, so let's see how we can implement that. So what I did was I first computed the prefix sums because it's going to be important later. Then just to ease out thinking about the problem, what I did was I stored in a double array, which is like n by 30. Yeah, n by 30. You can also just do this actually for it int j equals 0, j less than 30, j equals plus. We can just push back that. So we just push back the possible values for each pi, for each AI when we divide it by 2, and the others will be just 0, 0, 0. So yeah, that's the idea. Oh yeah, that's the idea. If we do log 2 of AI, minimum of log 2 AI and 29 floor divisions, the number becomes 0, right? So if we exceed the numbers at the last part, then it's just like, okay, it's all 0, so we don't care about that. That's why this is O of n log AI. So what I did was, the first possible answer is all bad keys, right? And that will be the sum of the first applications, the sum of the first 30 applications of bad keys, because at most all of them will be like 10 to the 9, if that makes sense, and the rest will be 0 at the end. And then I took the maximum of answer. Actually, you don't have to create a variable like this, so we can say just answer equals 0, and then we can do this, and then result, then answer. Just to not confuse anyone. Okay. Yeah, so we can do like result here, and then answer is just to make the code a lot better. And then for each answer, so it will be now result would be this, and then we take the result plus that, and then answer would be this, and then okay. So what I did here is basically we initiate the temporary result with the prefix sum minus k times I, because that's basically how many you can get from applying the first I chests using good keys. And then you take the rest to be bad keys, and at most it will be 30 bad keys, or actual positive values at most. Is it 30? Is it 29? It doesn't really matter. It doesn't change much. And then we update our answer, and our final answer would be that. So let's check if this code works, because I changed some. Maybe some implementation details become wrong after I changed a bit, but it's gonna be correct. One way to do this is actually keep dividing AI by 2, I guess. But just to be easy, I just made a new vector, but it doesn't really change much, right? So it's just the memory that we changed. And that's it. I had a good time yesterday. I didn't expect that I would solve all 7 problems, and I think so far it's also easy. The easiest competition I have participated in Codeforces. It's probably because I get better over time, or it's just easier, and it contains only 7 problems, because usually it contains like 8 or 9 problems. But yeah, that's basically it, and hopefully I get rating increase, and I will participate more rounds in the future. So yeah.